Welcome to the Explainer. Today, we're going to talk about how to architect a modern RAG stack. We'll take this whole complex ecosystem of tools and turn it into a super clear, actionable guide for your next build. Okay, so you've decided to build a retrieval-augmented generation application. You know, a system that lets a language model look up information from your own private documents before it answers a question. Awesome idea. But right away, you're hit with a huge question. Where on earth do you even start? You step into this world and wow, it is a dizzying, chaotic mess of frameworks, vector databases, models, and libraries. It feels less like a toolkit and more like, a giant word cloud of hype. It makes it almost impossible to figure out which Lego brick you're even supposed to pick up first.
But what if we're looking at this all wrong? The secret isn't to start by comparing a bunch of tools. Nope. The secret is to start by asking the right questions. It's not about the bricks, it's about the blueprint.
So, before we write a single line of code, before we pick a single vendor, we need to architect our plan. And the way we do that is by focusing on 4 foundational questions that are going to guide every single decision we make from here on out. All right, let's really get into this. First, what is the job of your app? A simple Q&A bot has totally different needs than a complex agent that has to call APIs. Second, your data. What are we talking about here? A few hundred static PDFs or millions of records that are constantly changing? Third, what are your real-world constraints? Things like latency, privacy, and your budget. Believe me, those will dictate your architecture more than anything else. And finally, how will you know if it's even working? You have to define what good means right up front. See? By answering these, you can choose every component with a real purpose, not just based on hype.
Okay, now that we have our blueprint, now it's time to choose our core building materials. Let's kick things off with the brain of the operation, the large language model itself.
Now, what's really cool about this is how it reframes the choice. It's not about which model is just better. It's about which one is right for your constraints. If you need total data privacy and you want to control costs, well, open models are your answer. But if you need top-of-the-line reasoning and you really don't want to manage a bunch of GPUs, then an API model is the way to go.
So, the key takeaway here is just don't get paralyzed. Use this simple rule of thumb. When you're just starting, prototyping, kick things off with a powerful API model like GPT-4 or Claude. It'll let you validate your idea really fast. Then, once you start feeling the pain of scaling costs or you're running into compliance walls, that's when it's time to start experimenting with self-hosted open models.
Next up, we need the glue to hold all these pieces together. This table does a great job of showing the different philosophies here. If you're building really complex workflows with agents and tools, LangChain's massive ecosystem is probably your best friend. If your main challenge is just getting great search results over messy internal documents, LlamaIndex is literally built for that. And if you're building a production-grade search system, Haystack's pipeline-focused approach is perfect.
And this shows how you should think about your system's long-term memory. Look, don't over-engineer it. If you're just prototyping with less than, say, 10 million vectors, something simple like Chroma is totally fine. As you move to a real production scale, you can look at tools like Qdrant, Weaviate, or Pinecone. And if you're building for a massive enterprise-level scale with tons of writes, then you'll need a heavy hitter like Milvus. Just match the tool to the job.
Now listen, we can have the best model and the best database in the entire world, but if our data is garbage, our results are going to be garbage too. This brings us to the foundation. A huge chunk of your RAG system's quality is decided right here, before a single vector ever gets created.
Your knowledge base probably doesn't start out as this clean, perfectly structured dataset, right? It's usually a raw mess of unstructured documents, complex websites, messy PEFs, and yeah, even PowerPoints.
The goal is to turn that mess into clean, meaningful chunks. And that means preserving the original structure, like sections and tables, in your metadata. It means chunking by paragraphs, not some arbitrary character count. And critically, it means using dedicated tools for the job, something like Firecrawl for web stuff or LlamaParse for complex documents, so you can attach really rich metadata. That way you can filter things and trace your sources. Remember this, great data extraction is often way more impactful than a slightly better LLM.
All right, let's be real. Building a RAG system without a plan for how to evaluate it, you're not building a product, you're just building a demo. To build something that's actually robust, we need a real quality control process.
And look, this isn't about picking one magic tool. It's a staged approach. You start with offline evaluation, using a tool like Ragus to just iterate on your core logic.
Then, as you get more serious, you add quality gates to your deployment pipeline with something like GIScard to catch any regressions. And finally, you instrument your live application with a tool like TrueLens to monitor real user traffic and actually collect feedback.
So, now that we have our principles and our components, let's see what a couple of finished builds actually look like out in the real world.
And this slide just perfectly shows how those initial blueprint questions dictate everything. The B2B SaaS Copilot, it cares about handling lots of customers and keeping the budget down. So that leads it to API models and a database with strong filtering. The internal policy assistant, though, it's all about data privacy and accuracy, which demands an on-prem open model and a self-hosted vector database. It's the same class of problem, but they have completely different and equally valid architectures.
So here's the crucial point. If you approach the build in a structured way, starting with your problem and your data, then picking your core stack for retrieval and language models, and then setting up a robust way to evaluate it, the tools stop being so overwhelming. They become what they're supposed to be, just interchangeable Lego bricks that you can pick with confidence to build exactly what you need.
So we've laid out the architectural plans. We've shown you how to think through the process from start to finish. You have the blueprint. The only question left is, what amazing application are you going to build with it?